Okay, my dear friends, this is the paper again, summer 2023, paper 6, variant 2, and we are solving question number 3 now. It's question number 3 of the same paper. A student investigates the refraction of light using a semicircular transparent block. Figure 3.1 shows her ray trace sheet. Now draw a normal through the center of the side AB. Continue the normal so that it passes through the curved side of the block. Label the normal NL and label the point C where the normal NL crosses AB. So first of all, center of this AB. When I am measuring, for me it will be different, for you people it will be different, because here zoomed in or something like this. So for me the AB length is 4.6. Yeah, 4.6. So its half is 2.3. This is the point which is the center. So we need to draw a normal, and I'm going to draw a normal at this point. Like this, a straight line, and it is said normal should be denoted by letter N, L, and where it crosses AB, label it C. So this point I'm labeling as C. Draw a line DC below the line PC at an angle of incidence of 20 degree to the normal and to the left of the normal. Now see, right now I'm not having the protractor with me, so I will do it roughly. We are going to draw the normal DC below the line AB, PC, and angle of incidence will be 20 degree to the normal and to the left of the normal, mean it should be on this side. So what I'm going to do, I'm making this C point up, and roughly I'm making it, let's suppose this is the 20 degree. This angle is how much? Roughly that is equal to 20 degrees. You will follow. And how will you put the protractor as the semicircular block? In the same fashion, same direction, you will put the protractor, and then you will start reading. It will be written here 0 and 180. So you can start 0, 10, 20. So this is 20 basically. And they said DC. So other end will be D. See, DC. So this is D. Then mark with neat crosses X the positions for the two pins on the line at suitable distance apart from this ray trace experiment. Label the positions P1 and P2, and we know that pin spacing should be at least 5 centimeter. So what I'm going to do here, I'm writing P1, and somewhere close here, this one I'm saying it as P2, because they said use cross sign. P1 and P2. Why P1 here, P2 here? So that the order P1, P2, see this is P3, P4 in order. So that is done for another one mark. Now some information is there. You can get this information if you are unable to understand the further portion of the question. Now see, draw a line joining the positions of P3 and P4. Continue the line to AB. Label E the end of the line furthest from AB. No problem. P3, P4 we need to join first. P3 and P4. So this way, and this is wrong by the way. I will draw another line because this line is not passing through these points. Again, now what will you do in exam? See, I did it and it was wrong. So roughly, first of all, what to do? Just try this way. Try this way. Yes, workable. So now make a straight line this way. And what is said? What should be the end of this line? Label E the end of the line furthest from A. So it means that this point will be labeled as E. This point is labeled as E. Then, my dear friends, let's keep on moving forward. Nothing from our side, just the instruction from the examiner. Measure the acute angle theta between the line NL and the line EC, and acute angle is less than 90 degree. Please, you people have acute angle between EC and NC. That's what I think. NL and EC, no problem. NL and EC. Basically, see, NL is here and EC. So it means you need to measure this angle. Please, my dear friends, measure it and let me know what is this angle. Because you are following the instructions, please measure and let me know. Yes, my dear. So answer from Muhammad Tariq 33. It's okay because answer should be from 30 to 34, any answer. So I will 33, 32, 34. So okay, I will write the in between value from all of you. So 32 degrees. State one precaution that the student takes to produce an accurate trace. You know, many answers, if you check the paper 6 key points I shared with you, view the bases of the pins. View the bases of the unit or use thin lines, even use sharpen pencil when you are drawing the lines. Many use sharpen pencil, that will also be workable. Okay, now what is there? The student replaces the transparent block on the ray trace sheet in the position shown in figure 3.2. Now the position is there. What is next? Just I sign. You can start reading. You can read this all, but I will be starting from here where there are marks. So now see, the position of P5 and P6 are shown in the figure. Draw a line joining the positions of P5 and P6. Continue to line C. Label G the end of the line furthest from AB. So now P5 and P6, we need to join them till it reaches C. P5 to P6 till it is going to C. Yes, almost okay. Okay, so this is the line now. Next, label and G. Label this end of the line furthest from AB. That is G. See, very clearly mentioned. Label G the end of the line furthest from AB. So the other end. Measure the acute angle again alpha between the line AB and the line GC. Acute angle is less than line AB and GC. Line AB and GC. So this is the acute angle, my dear friends, because this angle will be greater than 90. So this angle we need to measure, and it is 60 plus something like this. Please measure it. Measure this angle, and the ruler, sorry, protractor same angle as it is here. So you will read here 0 and 180, start from 0, 10, 20, 30 like this. Please measure it and let me know what is this angle. Measure the angle and let me know. Measure the angle and let me know. Two answers are there. 69, 70. Who else? One more. Two options are there. 69, 70, 69, 70. So okay, fine, I will be writing here 69, no worries. 69, 70, so this angle alpha, that is equal to 69 degrees. Calculate beta between the line GC and the normal NL. BC and the normal NL. Very simple. Simply beta will be equal to 90 minus 69. Why so? NL is basically normal. We did not draw the normal here, by the way. So NL is the normal. So it will be 90 minus 69. So it is equal to 21. So here 21 degrees. Yes, so NL is not shown there. So you can draw here even. This is NL. Roughly I am drawing. This one is NL, and now he wants this angle beta. Anyhow, now a student suggests that the angle beta should be equal to the angle of incidence 20. So state whether the results is yours. State whether your results support the suggestion. Justify your answer. So we will say yes, and here I am going to write within the limit of experimental accuracy. Why did I write like this? Because I know the percentage error is less than 10%. How to find it? No need to show to the examiner, but you can check just percentage error or uncertainty 2 times the difference between the values 21 minus 20 over 21 plus 20 times 100%. Please, can you check what is the answer and let me know? Yes, my dear friends.
Zero.
It is 4.0. How am sorry, Mariam, it is 0. It is 4.87. So we can make it like 4.87%. Let it be 5%. So uncertainty or error is 5%. Your answer is 95% accurate because 100 minus 5, 95%, which is a high ratio of accuracy. So yes, statement always yes or no, and if it is yes, within the limit of experimental accuracy. If it is no, mean answer was 14%, 15%, so it was more than 10%. It means just statement will be no and justification outside the limit of experimental accuracy. So in this way we can proceed this experiment, and if there is any question, please feel free, you people can ask me now. Is it fine? Now let's move to the planning question. A student investigates the change in current in a conducting liquid, electrolyte you can say, as the distance between the two electrodes is changed. So it means change in current is dependent variable because it depends on the distance between the electrodes. Dependent variable, and the distance which is between the electrodes, this distance, it is independent variable. Independent variable. These points are very important, dependent and independent variable. Okay, now plan an experiment to investigate the change in current in the liquid as the distance between the electrodes is changed. So circuit is there. See, this is power supply, power source, power pack, anything you can say, a switch, an emitter to record the current or to measure the current, changes in current, and the distance between the electrodes. So explain briefly how to do the investigation. Very simple. You can say, I will start saying like this, that connect the circuit. Let's just start like this. Connect the circuit as shown in figure above. Then measure the distance between the electrodes and measure the current in the circuit. The current in the circuit, but always remember, never ever this how to do the experiment will never be completed if you are not writing this, that repeat the same method by using different values of distances between the electrodes. Why distances? Why not current? Always here when we are repeating, we are changing the independent variable, and in this question independent variable is the distance between the electrodes. So repeat the same method by using different values of distances between the electrodes. So this is the method which we are going to follow. Next, state the key variables to be kept constant. So there are only 4 points. One key variable is use the same potential difference or battery. Volume of the liquid which is working as an electrode. Also, here they said key variables. It means we have to write at least 2, and we will write 2. So first of all, current we are measuring. So the source of current, which is supply of voltage source, it should not be changed. I'm going to write now the next point, that potential difference and volume of liquid or electrolyte even the depth of the electrolyte electrodes into the liquid, that will also matter. Concentration of the liquid will also matter. Why I'm writing liquid spelling wrong today? Liquid, liquid, electrolyte must be kept constant, or you can write must be controlled. So after this, next is draw a table. So only 2 column headings we need, and they are, number 1, you can say, see independent variable in the beginning, distance in millimeters, and current, or better to write changes in current because they are asking changes in current, and delta I in amperes. This will be the table. Then next, of course, it will be how to reach a conclusion. So for that purpose, plot a graph of changes in current on y-axis because it is dependent variable, against distance on x-axis to reach a conclusion. to reach a conclusion. And as usual, better to write one more precaution, you can say that take at least 5 sets of data. Take at least 5 sets of data. So in this way, your all marks are, all points which are asked, they are discussed in the question. One thing more here, it is not necessary that you should write all the time plot a graph. Even in this case, you can say compare the readings or compare the results to check by if the changing distances between the electrodes are causing the current to be changed. So like this also you can write. Or better to say plot a graph. And again, most important thing is in this question, first of all, you have to identify that which one is independent variable and which one is dependent variable. And even when we are writing the table, independent variable comes in the first row, first column, and the dependent in the last if there are more columns. Also, when we are repeating here or we are telling the method, so measure the distance starting from the independent variable between the electrodes and measure the current in the circuit. And when we are repeating, even repeat the same method by using different values of distances between the electrodes. So these things are important always to monitor first or to recognize first which is independent variable and which one is the dependent variable. My dear friends, any question on this, please feel free, you people can ask me. Okay, my dear friends, in this way this second portion of this paper is done. Stay blessed.